Seeking English S.A.T. Workbook, page 434, problem 4. I know it often sounds like I'm saying bad things about algebra teachers or about algebra classes, and I don't want to give you the impression that that is actually my basic attitude toward algebra teachers or algebra classes. The reason it sounds often like I'm saying negative things is that most of my job here is to get you to answer multiple choice questions. And that is mostly not what you do in algebra class. That's the basic difference. That's why for most of the problems on the S.A.T, attacking them exactly the way you would attack a problem in an algebra class is probably not the best strategy. Okay, and questions where you have to write the answer in, most of the time, your best mode of attack will be exactly what a good algebra student would do in a good algebra class. So if you want to show your algebra teacher a video from my series to assure them, no, Josh loves algebra teachers, maybe show them this video. Okay, what do we have? This may not look like a quadratic, but if you look at it more carefully, it may begin to look to you like a quadratic. Take a minute, okay? Now that I've told you it's square, I know it becomes obvious afterward. Hopefully, a similar problem will seem almost as obvious on the real test, or even more obvious, I don't know. This x is greater than 0. This is going to come back, so I'm going to get it out of the way. Okay, just take it down here to get it out of the way. It's going to come back. Okay. In the meantime, this, if you spot it as a quadratic, then solving it as a quadratic consists first of the step of reducing it to something that is easier to recognize as a quadratic. How do you do that? Well, first take out anything that doesn't need to be there, anything that's redundant. What is redundant? This is obvious to some of my students, not to others, and so I want to make sure that if you're one of a significant number of students to whom this is not obvious, that you see this next point. Okay, this x to the third is 3x's. You look at it this way: x times x times x times that thing. Okay, and this is 36 times x. If I put it that way, hopefully it's more clear that you can get rid of this x and this x. Okay. That takes us down to x squared, and then there's that. Okay, before you move this to the other side, before you do that, I'm going to suggest that you simplify this by multiplying it. Multiplying doesn't simplify. Yeah, it does. Often it does. Let's try this. It comes x to the fourth minus 13x squared equals minus 36. How is that a simplification? Well, to me, it's a simplification because the parentheses are gone. Parentheses don't usually indicate something that has been simplified. It's usually the opposite. Getting rid of parentheses is a hint that something's been simplified. Okay, from there, it begins to look a little bit more like a quadratic. So I'm going to, rather than write this again, I'm going to change that minus 36 to a plus 36. There equals 0. And I say, but teacher, there's a 4 and a 2. Okay, that's one way to look at it. That's one way to look at it. I'm going to look at it like this. It's going to be x squared, okay, minus 13x squared to the 1 plus 36x squared to the 0, which is how I look at everything. If something's not there, it's actually a 1, it's a 0 exponent of something. I know, really complicated, I know. But take a moment. If this helps you at all, it's worth me mentioning in this video. If it is not helpful to you, yeah, forget about it and come back when you get curious. Okay, that's how I look at this. This is how I know it's a quadratic. It's something squared, something to the 1, and then something to the 0. For me, that's what's really going on in a quadratic. And if your algebra teacher is watching, okay, from there, how am I going to do this? I'm going to go back to this expression. If we solve for, okay, if we solve for x squared rather than solving for x, we can, remember this is x squared, right? So instead of solving for x, okay, we're going to solve for x squared. Then later we can use this to figure out what is the square root of x squared. That's why I saved this. That's why I don't want you to forget about it. So let's put it through the process. Assume we're solving for x squared instead of x. Again, write this a million times. Don't be afraid to write it out every single time, Okay? Okay, write it out every single time until it becomes automatic. Less can go wrong when you have to write it out on the test. Okay? B squared minus 4ac over 2a. Okay? That's a lot of writing, I know, but it prevents errors. Okay, so what is 1? A is 1, it goes away. I always like to do C next, and again, algebra teacher, hi. Okay, 36 here is going to be C. Okay, from there, 4 times 36 is 144. Yeah, okay, this is minus, this is, yeah, that's 13. 13, and there, 13 squared is 169 minus 144, okay? So square minus a square. Would the difference also be square?
It could be.
It could be. Should be 25. Okay. There. Square root of 25 is 5. And I know these are odd numbers, and you see this again and again and again in this practice material. It's an odd number, no, okay, no. If you provide these two solutions over 2, you can then reduce them easily because they will be odd, it's going to become even. 13 plus 5 is 18. It's going to be 18 over 2. The other solution is 13 minus 5, which is 8 over 2. Okay, so that becomes 9. That becomes 4. And we're going to take these square roots. Remember, we solve not for x, but for x squared. And that is where a lot of students also go wrong. Square root of 9, square root of 4, and it says x is greater than 0. So it's 2 possible solutions are 3 and 2. You are only required to give one of these answers. Okay, so don't fuss about which one. Give one quickly.